My name is Emmanuel Ikegwonu. I'm a research engineer at the National Center for Energy and Environment. It's a research institute under the Energy Commission of Nigeria, right? And I'm a graduate of mechanical engineering. I graduated from the University of Benin with a bachelor's degree in mechanical engineering, and I've taken on roles across different sectors from product design engineering, additive manufacturing across a range of companies and startups. So I'm going to be giving you guys tips and strategies for developing an impactful portfolio, a portfolio that can help increase your chances of getting into um, advanced engineering roles or even scholarship programs, right? So, as Bilal has already said, attaching a portfolio, a well-designed portfolio, can actually give you an edge over other applicants in different programs, right? So imagine one person is just submitting his CV, and then you, on the other hand, you are submitting not just a CV, but a document that properly structures the different projects that you've worked on. The hiring manager or the selection committee, they will be more likely to pick you over others because they feel like you have the evidence to show, right? So that's what I'm going to be doing here today. I will be giving you tips and strategies on how to create a wonderful portfolio, and I will also give you um, I'll also refer you to different sources that can not just help you create a good portfolio, but also help you improve yourself generally as an engineer or an aspiring engineer. Sources that can help you um, expand your career or improve your career as an engineer. So I think I'm going to be sharing my screen. I'm a big fan of PowerPoint presentation slides because it gives events like this a little bit of structure. So I'm going to be sharing my screen so that we can look through the slides, and I'll also show you a sample of a portfolio. I'll show you a sample. I'll give you different resources that will help you maximize the portfolio. So let me just quickly share my screen. Please, I want to confirm that you guys are hearing me. So if you got all I just said, just indicate just raise your hands, please.
Yes, we
Okay.
can hear you.
Okay, fantastic, fantastic. So you can see my screen, right? Is my screen
Yes,
visible?
yes.
All right. Okay. So let's get to the issue of the day. Now, a guide to building the perfect design engineering portfolio. Before we go ahead, I'd like to give clarity on a certain issue, right? So there is a difference between a designer and a design engineer. So a lot of the mistake I find uh, young engineers doing nowadays is that they can't tell this difference, right? So a designer is someone who primarily focuses on aesthetics and visual form. So um, not talking about the UI UX and the program and stuff. I'm referring to the engineers who are acting as designers. So they mostly focus on CAD models. When I say CAD models, I'm referring to computer aided design models. So I'm going to be saying CAD models a lot here. So whenever you hear that, just know I'm referring to computer aided design or 3D design. So I find a lot of young engineers, uh, they think they are design engineers, but they are mostly designers in the sense that CAD designs are usually the final product. It's usually the final output of what they do, right? So there is a big difference. A design engineer is not limited to just CAD or 3D design. A design engineer uses CAD as a foundation for technical outcomes, right? Solving problems under constraints. So CAD is usually a starting point for design engineers. So my recommendation is, if at this stage your skill set is limited to just CAD, I will advise you try to learn an additional skill to complement CAD. because that is what is going to make you qualified to call yourself a design engineer. So by additional skills, I mean you can either go for manufacturing. So you know that whatever you are designing for the purpose of manufacturing. It can be additive manufacturing, it can be subtractive manufacturing, it can be formative manufacturing, anything. Just ensure that whatever you are designing, you can also manufacture it, right? And then there is designing for the purpose of analysis. We are referring to the simulations now, right? Like finite element analysis and the computational fluid dynamics, right? So you know that whatever you are designing for the purpose of using them for advanced technical analysis, using tools like ANSYS, COMSOL, Abacus, and others, right? So that's why I attached these three images you can see here. This first image is a CAD model, right? Anybody who is limited to just doing CAD model is a designer, not a design engineer. And the next image is a CAD model that has been produced with additive manufacturing, right? So at this point, you are beginning to operate like a design engineer because you are not just designing a model, you are applying what's known as a design for manufacturing, or in this case, design for additive manufacturing, DFAM, right? You are applying these principles in order to bring this 3D design to reality. So at that point, you've gone beyond being a designer. You are now operating as a design engineer. And in the third image, you can see a static structural analysis of this is a phone stand, of the phone stand. So in this case, the 3D design that was generated initially has been used to carry out a simulation to determine if this product we designed will be able to withstand the stress or the load of placing a phone on it. So you have stress contours that enable you identify what areas are experiencing the maximum stress, and it gives you information that can help you optimize the design, right? So anything beyond this first phase, you are now operating as a design engineer. But if this first phase is the best you can do, you are still a designer. And what I want to tell you today is it doesn't matter how beautiful your portfolio is. If you are operating just as a designer, it will be difficult for you to outcompete others who are operating as design engineers, right? So the first advice I'm going to give is, if all you know how to do is CAD, whether it be SolidWorks or CATIA or Fusion 360, try and learn an additional skill that builds on that CAD. The additional skill can be manufacturing or it can be analysis, right? So when you've been able to get any of these in addition to your CAD design skills, then you can create a portfolio that's highly rated, that can be highly rated by a reviewer or a selection committee. Uh, okay, hope that's clear. Sorry, I'd just like to know if people are following when I'm giving a talk. So please, can you just did you guys get all I just said now? Hello.
Yeah,
Okay. Okay. Beautiful. Now, what's a portfolio? In simple terms, a portfolio is just a curated document demonstrating your engineering ability through evidence, right? It lets you show what you have done in the past in a way that communicates competence, depth, and judgment. So, the purpose of submitting a portfolio, or the purpose of going through portfolio, um, on the part of reviewers and selection panels, is they are trying to answer a simple question: can this person solve the kind of problems we face? Is this person qualified to work on the kind of projects that we work on? That is the question a reviewer is trying to answer when he goes through your portfolio. As such, it's best to structure your portfolio in three key sections. I know I listed four sections here, but there are three main sections that every portfolio should have if it wants to stand a high chance of being highly rated, right? So your portfolio must have a project section, right? So it should show the projects that you worked on, the problems you addressed, and the outcomes you achieved from those projects or from that problem. Then the project section is the most important aspect of a portfolio, right? So if I were to give if I were to rank these criteria as to how important, or if I were to rate these different criteria as to how important they are for a portfolio, I give the project section 80 or 85%. So in a sense, if all you have is the project section in your portfolio, that's actually good enough. While the other two are the award section and the certifications section. So the award section, they just give like an external validation of quality, excellence, or impact, right? So they prove to the selection panel that you are capable, right? It's like an evidence of your capability or your capacity. They see that you've won some very nice awards, right? So, and then there is the certifications section. Now, this certification section shows them, it demonstrates to them, especially in terms of if you're applying for scholarships, right? The certifications area tells the selection panel that this guy is willing to put in the work. So it shows the formal training, technical exposure, and professional development, right? So, and then the skills. Why I don't consider skills and tools as a primary section in a portfolio is because it's it falls within the project section. So when you are talking about your project, it's good to highlight the skills or the tools that you use in executing those projects, right? That's why, to a large extent, it doesn't have to be a separate section on its own. So just to recap, a portfolio is a document that demonstrates your ability through evidence, and it should contain three main sections. Projects, which is the most important, I'll give it about 85% importance for your portfolio. Awards and certifications. Those are the three main sections you should likely have in your portfolio. Now, there are different formats for creating a portfolio, right? So there are three main formats. There is the PDF format. Now this is the best for design engineers like us, hardware engineers generally, because it lets you give visual details on the projects that you've worked on, right? It allows for structured storytelling. So, and then there is the GitHub portfolio. Now, this one is mostly ideal for software engineers, software focused roles. You should have friends who are programmers who always talk about GitHub repository and all that. So, the GitHub portfolio is ideal for software engineers. In a way, in some sense, it would be nice if we design engineers or hardware engineers had our own version of GitHub, right? That is just built to offer that visual quality that is required for from a design portfolio. So if we had our own hardware version of GitHub, it would be nice. So if you have friends who are programmers, you can pitch the idea to them. And then on a more advanced level, there's the personal website. So it can be used by both hardware and software engineers, right? So your own personal portfolio website is more complex, but I think I would say it's the more advanced version. But in our case, the PDF portfolio is a good way to go, right? It's a good way to start. So you create your portfolio using softwares like um, Microsoft PowerPoint or Canva. I personally I prefer Canva, but you can use other tools. And if you are applying for a program or a job application, you can if there is a section that allows you upload your portfolio, you can easily add it. But if that section does not exist, you can easily upload your portfolio to your Google Drive and attach the link to that Google Drive to your CV, right? So either way works. So these are the three main formats for a portfolio, but we'll be focusing on the PDF format. Now let's look at some rules for a strong portfolio. Now, if you want to have a high quality portfolio, a portfolio that will leave your reviewers in awe, it should tell a story, it should demonstrate technical skills. Like there are five main rules that you should follow. First, your portfolio should be tailored, right? So I understand that as design engineers, we may have worked on numerous projects across numerous sectors. Maybe today you designed something for the energy sector. Tomorrow you design something for interior decoration. Next tomorrow you design something for the automobile. As a design engineer, you can work across sectors. So you may probably have different projects in different sectors, but you should tailor your portfolio to suit the specific sector that you are applying to. So when you are applying to for a product design role, okay, you can attach your most relevant projects across different sectors. But when you are applying to like an energy for an energy role, select projects that are that are around the energy sector, that were built around the energy sector, right? So just tailor your project to the specific sector that you are applying to. So in a sense, it would be nice to have a master portfolio. I'll show you guys a sample of a master portfolio. So a master portfolio that like has all your projects, like all, regardless of the sectors, all the projects. So when you are applying, if you are applying for an energy role, you just pick out the ones that are associated with the energy industry. If you're applying for a different role, you just pick out the specific roles that are associated with the specific sector you are applying. But it would be nice to have a master portfolio, like just one large document containing all the projects that you've worked on. I will show you a sample soon, well, when we get to after the next two slides. So, secondly, your portfolio should tell a story. You should show your thought process, not just the final output. See, when designing a portfolio, it's easy to make the mistake of just putting a picture of the project, of the final project, or the final design, or the final simulation, just putting it there and saying, um, uh, this we did this, and this is the design, right? That's too it's too limited. So in your portfolio, try to tell a story. And the process of telling a story goes like this. You have a what section, a how section, and a result section. So the what section will say, what is this? What is the goal? What was needed? What is this project? The how section explains how you went about this project, and the result shows the outcome of the project. So it should be a progressive structure, right? And it should tell a story so that the recruiter or the selection panel or the reviewer, he's going along, he's seeing your thought process behind every project that you're putting, right? He sees the thought process. So even if he doesn't feel like the project is impactful, the methodology itself might attract him or her, right? And then show hard technical skills in your portfolio. So that's why I said if you are creating a design engineering portfolio, if you notice in the intro, I used a guide to building the perfect design engineering, not just design portfolio, design engineering. Because a key rule that you should follow to creating a high quality portfolio is to show hard technical skills. In that sense, your skill set should go beyond just CAD modeling. You should be capable of doing more than just designing. Because the truth is, anyone can design. That's a harsh truth. If you take a secondary school student, you give him a laptop, you give him a good environment, he will learn how to do 3D design with any design tool. It's easy, anybody can do it. It's the bare minimum. But what then differentiates you from this bare minimum is what you can add to your CAD design skills. That's where simulation or manufacturing comes in, right? So your portfolio should reflect these hard technical skills. In your portfolio, if you design the product and you manufactured it, it should show the design, show the manufacturing process, show the final output. Same goes for simulation, right? So as I said earlier, if all you know how to do is design, try and get an additional skill, whether it be finite element analysis, computational fluid dynamics, material selection, or manufacturing. Try and get an additional skill. So, because the truth is, most companies they don't just hire you to come and do design, right? They hire you to come and do engineering work. So, if you only know how to do design, it really won't be enough, right? And then focus on impact. This is another important rule that you should follow. As well as you are telling the story, in the results section of your story, you should try and give quantified impact, right? Uh, don't just say, okay, we reduce manufacturing costs. Say, we reduce manufacturing costs based on this strategy that I employed. I was able to reduce manufacturing costs by so and so percent, 15%, 20%. try and give quantified impact so that they have an idea of how important it is this strategy that you implemented is, right? And then try and make it clear and current. In some cases, if you are going, you can go with different strategies for your portfolio, right? You can decide to have 10 good projects on your portfolio. In that case, try and make them a bit summarized, right? Don't, it should not look like an entire research article. It should be a bit summarized because the recruiters, they have a lot of portfolios. They probably have a lot of portfolios that they are going through. So they won't have the time to go through all in this step. Or you can decide to go with your three best projects, like the three highest impact projects that you know that you've done. You can decide to put those three and then explain them a little bit more than you would have done, right? Give a little bit more than just a summary. So, in simple terms, you either go for 10 or more nice projects and give summarized details of each project, or you go for 3 to 5 of your best projects and explain them in detail. So that's rules for a strong portfolio. Now, okay. Remember I said in the first rule for a strong portfolio, getting a tailored portfolio, I said it's very likely that you've done a lot of projects for across different sectors, and in that case, it would be nice to have a master portfolio. So I want to show you a sample of what a master portfolio might look like. So just indicate that you are following, please. If you are following, just indicate, please.
Yes.
Okay, okay, thank you. Now, I'm sorry I have to keep asking. I like to, I don't like feeling like I'm just talking to myself again. So I just have to confirm that people are actually listening. So this is an example of a master portfolio. So this portfolio, it contains all the different projects that I have done, or the best projects that I have done, and they are across different sectors. First, you have something related to batteries, then you have something related to biofuels, that's energy, then you have something related to automobiles, like all the different projects that I've done across different sectors. I have all of them on a master portfolio. So if I'm applying for one role, this one now is related to UAVs and the additive manufacturing. If I'm applying for a specific role, I'm going to pick out those that are relevant from this master portfolio and use them in my application, right? I'm not just going to submit everything. The purpose of this master portfolio is just so that I have one area, one document where everything that I have worked on or the best projects that I feel that I have worked on are available, right? So you should have something like this for all your projects and then pick, tailor it to whatever program or job you are applying for. Okay, so now let's focus on the most important section of your portfolio, which is the projects section. Now, the project section is the backbone of your portfolio. Without the awards and the certification section, the portfolio is still good enough. It still stands. Like I said, the project section carries about 85, even 90% of your portfolio. So this part is a must-have. You can ignore the rest too, but this part is a must-have. So as such, it's advisable that you structure it properly. Now, as I said before, this your project section should be divided. You should tell a story with all your projects. Don't just put one picture and put one explanation of what's in that picture. No, tell a story with your project, and that story comes in three key areas: what, how, and results. I'm sorry, I should have put it. I should have indicated them here. Let me just write it down here. What, how, and results. These three sections should be available in the project section. This is how it should be structured. So the what is the problem definition. You describe the objective, the constraints, and the significance of the project. You are telling the reviewer, you are basically describing, giving an overview of the project to the reviewer, right? And then the how shows the approach or the method you took in taking on that project. It explains your design process, your assumptions, your tools, and engineering methods. The problem can be okay. Um, I I improved the performance of a vehicle engine. Then the how can be something like I carried out 3D designs using SolidWorks. I carried out fluid structure interaction using ANSYS, employed design for manufacturing principles. It's just explaining the strategy you took to taking on that project or that problem, right? And then the results and outcomes involves presenting measurable results, performance improvements, and lessons learned. As I said earlier, the results should be quantified, right? Some results might not be capable of being quantified. That's okay. What's important is that most of your results, there is a level of quantification in majority of your results. Did you reduce weight by 5%? You reduced 3D printing time and 3D printing material by 15%. That's what you should cover in the results section. So let's go through this sample and let's go through this sample and see how each of them is applied. So in the portfolio, generally you have your name, right? And like I said, in the portfolio, you have a project, awards, and certifications section. So in mine, in the project section, I ensured that it was red while the others were black. That's to indicate that this is the project section. You can do it anyhow you like. Like there's no specific rule. So feel free to be creative in your own case, right? So in the project section, you have a project topic. In this case, the centralization of a modular bioethanol distillation unit. This is one of the projects I did in my current role at the National Center for Energy and Environment. So the centralization of a modular, you see, I put the title and underneath I put the organization which it is associated with, right? So that's the first thing we put. And then this is the what. This is the what. Now, the bioethanol distillation unit developed by the NCCE is energy intensive, which keeps it heavily reliant on grid electricity. That's the first paragraph. Second paragraph, the Nigerian electrical grid is unreliable with frequent power outages, which hamper the system's ability to operate effectively. And then finally, the goal here is to minimize electricity consumption and develop a system that will attain some degree of independence from the national grid. Now, these three paragraphs just explains the entire what of the project. So from these paragraphs, you've understood the problem and you've understood the goal, right? The objective. That is what the what section should capture. And then as a design engineer, you have to add pictures, right, of your design, right? So this is in the what section, you have a picture of the base model, right? So like it should not be the final product or the final outcome. In the what section, put the original form. In this case, this is what the bioethanol distillation unit looked like. So this was the original form. This was how it is when I took on the project, right? And then the how, developed a dynamic simulation model in MATLAB slash Simulink. So you see, I highlighted MATLAB and Simulink. That's why if you remember, I said in the four sections of a portfolio, I like to go with just three of these sections because the skills and the tools section they are usually outlined in the projects, right? The skills and the tools they are usually outlined in the project section, right? So that's uh that's what's going on here. You can see instead of me to have a separate section explaining the tools I know how to use, I've indicated it here using MATLAB and Simulink and I highlighted it, right? To quantify the energy demand of the entire system and its individual subsystems. Energy demand was found to be 5.78 kilowatt hour per batch, with about 87% dedicated to electrical heating. Then I came again and said the optimization strategy involved replacing electrical heating with solar heating, taking advantage of abundant sunlight in Nigeria with the help of evacuated tube solar collectors. Like this is just the how. Now in this how, I've explained what kind of simulation I carried out, what tool I used in the simulation, some of the discoveries made in the process of carrying out this simulation, and the strategy implemented in optimizing the system. So this is the MATLAB model that I developed for the system. You see now, the portfolio is not limited to just a 3D design now. You can see there is a design, sure, but it is backed by a simulation, a dynamic simulation using an additional tool, which is why I have to reiterate, if all you know how to do is 3D design, is CAD, you have to try and develop an additional skill. It can be manufacturing, it can be simulation. So don't limit yourself to just 3D designs, right? So I also showed from the simulation how after carrying out the simulation on MATLAB, I discovered I was able to model the energy consumption by the different subsystems. So I put the image of the graph that shows energy consumption over a time period, and then we come to the results. In the results, I have achieved a quantifiable 87. Notice now, this is a measurable impact. This is a quantified impact. 87.38% reduction in grid energy consumption, right? That's a measurable impact. In economics, with average annual savings of 377,000 naira and a payback period of 3.6 years. These are measurable impact. These are quantifiable impact. You should not just say I achieved energy consumption. Say I achieved energy. You should not just say I achieved reduction in energy consumption. Say I achieved reduction in energy consumption by so and so percent. Don't just state the result. Ensure that a quantifiable metric is attached to that result that you are stating, right? In sizing, I said 100% grid independence is attained by integrating a 2-meter square evacuated tube solar collector and 400 to 450 watt solar PV with 4 lithium ion cells into the system. So you see everything, there are figures attached to it. It's not just a generic statement. And finally, I'm showing the final CAD model, the final 3D design, right? So this is the final state. Initially, all you had was the bioethanol distillation unit. But now, after the analysis with an additional simulation tool, I used 3D design again to show my final product, the results of everything. So this is the evacuated tube solar collector. This is the solar panel. And then the requirements by the center was that most of these things be mobile because they have to be tested in the field. So that's why it's done like this with wheels and all that. So you can see that 3D design is involved, but it is not the only thing. It's not, the portfolio is not limited to just 3D design. If it were just 3D design, it's I would be limited to a designer in that case. But since we are all design engineers, there has to be something extra. It's not you don't have to you are not supposed to limit yourself to just CAD design. If you know how to use SolidWorks, learn SolidWorks simulation, right? Learn SolidWorks for additive manufacturing, right? And then build on these skills. Build on these skills because that's what qualifies you to be called a design engineer, and that's what qualifies your portfolio to be top tier. So you can see the difference between my what, my how, and my result. In my what, you can see that there was just a 3D model of the bioethanol distillation unit. But in my results, you can see now that it's both the bioethanol distillation unit and the solar collectors, right? So, and in the how is the simulation process. So this is how you tell a story. You don't just put one picture and say, I developed a bioethanol. No. Your portfolio, as much as it should be visual, it should be structured. A what, a how, and a result, right? So these are just some other projects. Hybrid bioethanol biogas production system. It follows the same process. A what with an initial image, a how with the simulation process, and the result showing the final graph. Same with this, like everything is just following the same structure. What, how, result. Everywhere you look is the same thing. What, how, result. Right? So that's it about structuring the project section. Define the problem, explain the approach or the methodology taken to address that problem, and explain the results and outcomes of that methodology using quantifiable metrics, right? That's how you tell a story with your project in your project section. Do this for all the projects you have, and ensure that you are not just listing design projects, right? We'll get to a point. I'll show you how you can you can create a portfolio around just design projects. You can do that, but then if you want to stand a higher chance, as I've been saying repeatedly, you have to know more than just CAD design. So that's for structuring the project section. Now, questions that can guide you in creating a focused portfolio. So these are a list of questions that you should ask yourself if you're trying to create a focused portfolio. Now, in this case, um, we are assuming that you already have a master portfolio with all the projects that you worked on, right? You have a master portfolio. Now you are applying for a specific role, and you want to guide yourself to create a tailored portfolio to that specific role. You ask yourself, what position am I aiming for? Let me use myself as an example. Say I want to apply for a role as a research engineer in a company like what's a popular company now, like Apple, for example. Say I want to apply for a role. Okay, no, let me say Tesla. Yeah, Tesla seems more mechanical to get. So I'll ask myself, what role am I applying for? Okay, I want to apply for research engineering role at Tesla, right? What? Okay, that's the position. What work does this company do? Tesla, they are automobiles, electric automobiles. So I think, okay, what aspect of the electric automobiles do I want to be involved in? Let's say battery systems. Then, what are the day-to-day responsibilities? This is where you do your research on the company and the job opening. If there's a job opening, you also have to look through it because they will often give a list of qualifications that they are looking for and then job responsibilities to tell you as a when you apply for this role, if accepted, this is what you are going to be doing each and every day, right? So you understand those day-to-day responsibilities. You can watch videos on YouTube too. There are a lot of people who do videos on a day in the life of a mechanical engineer at Tesla. You watch videos like that, so just to get a glimpse of what working at such company is all about. You can also reach out to current staff or former staff, people who have worked at that company, either in full-time roles or as interns or as contractors. You reach out to these people and talk to them, reach out to them on LinkedIn, talk to them, ask them what are the day-to-day responsibilities so that you have an idea of what you are trying to get into. What engineering problems are common? This is another question you also have to have. You should also ask the if you reach out to staff or former staff of the company you are trying to apply for, you can ask them the same questions. What engineering problems are common? You can watch videos too. You can work with AI models, right? ChatGPT, ask ChatGPT what engineering problems are common, or what engineering problems do research engineers at Tesla usually encounter, right? So the engineering, if for someone like me now, if I want to go into the battery systems, I just understand that the main engineering problems will have to do with battery thermal management and uh, integration of the battery pack into the chassis and those other things. Just get an idea of what they are, and then understand what tools and methods are used. What software does Tesla use, both for design and analysis? Understand all this. Then look through your portfolio. Look through your portfolio and try to match it to the answers to these questions, right? Like for example, if I say what position am I aiming for? If I'm aiming for a research engineering position, then I have to look for projects in my portfolio that have involved me carrying out research in an area related to automobiles, right? So using this as a sample, say I want to apply for research engineering role at Tesla, then obviously a project like this, a project like this now, battery pack design and sizing or battery pack thermal modeling, I know that I can take this out of my master portfolio and put it in my tailored portfolio when I'm applying for Tesla, right? Because it's relevant. Then, what work does this company do? They're into electric automobiles, same thing. What are the day-to-day responsibilities? What engineering problems are common? You just take the answers to these questions, take the answers to these questions, and match them to the projects you have in your portfolio, and try to pick those projects that are related to the answers to these questions. Pick those projects and put them in a tailored portfolio. Or sometimes what I like to do is, if I see the if I've gotten an answer to these different questions, I try to come up with a project, one single project or two projects that are similar, that align with these answers, right? So this is where you can also use AI models. You send this question to an AI model, tell it, I want to apply for a role at Tesla, and I need you to help me come up with a list of 10 or 20 projects that would match the answers to these questions. And then from those projects, you pick like one or two, learn them, work on them, and put them in your portfolio. You understand? So these are some guiding questions to help you tailor your portfolio to the specific company that you are applying for. And finally, a common problem that I feel many people will have is, what if I don't have any design engineering projects? Right? It's easy to see, it's easy to show people your portfolio, but most people don't know that what I'm showing you guys now is like a product of like almost 2 years of work, right? So there are some people who are just starting out. So you might have this question: what if I don't have any design engineering projects? Well, the answer to by design engineering projects, I'm referring to both those who don't know how to do design and those who don't know how to do simulation. And at the same time, I'm referring to those who only know how to do design. As I said before, if all you know how to do is CAD modeling, then you are still a designer. You're not yet a design engineer. So I'm referring to these two groups of people. So here's what you should do. First, work on personal projects or build on your personal projects, right? Go beyond visual design, build prototypes or use simulations. Let's say you designed something, for example, you designed you designed a phone stand, and all you know how to do is design. All you know how to do is design, and you've designed a phone stand. Now the next thing is, you tell yourself, okay, I'm going to learn 3D printing, or I'm going to learn how to use simulation tools like ANSYS, right? You learn those tools and you use that design that already exists, that you've already created, to practice, right? So you do carry out a simulation on that design, you verify or you validate it, and then it not just helps you get better at using those tools, it becomes something that you can then use on your portfolio. There are some people who, a lot of people graduate without doing projects. It's common in Nigeria, given the education system and all that. We don't really do a lot of practical work. It's usually theoretical work. So when you have personal projects that you've worked on, it becomes fair for getting into entry level roles, right? It becomes fair. At least it also puts you at an advantage over others who don't have any project at all. So work on or build upon your personal projects. If you have designs that you've done before, learn simulation and use those designs to practice your simulation, your knowledge of simulations, right? And then collaborate. Collaborate. There are a lot of lecturers, and you have access to lecturers, and these lecturers, they are constantly trying to publish articles and do research. At the same time, there are a lot of students who are very technically skilled. Someone like a Bilal now, I know Bilal has almost like 200 SolidWorks certifications, and he's very good with ANSYS too. But he's very good with ANSYS, FEA, CFD. You know someone like Bilal, meet him and tell him you want to collaborate with him. What project are you working on now? Let me assist you on it. Let me work with you on it. And you learn from him, right? You learn from experienced engineers too. You reach out to people on LinkedIn. Tell them you want to learn from them. What's your next project? Say, I don't mind doing it for free. That kind of thing. You tell them, you let them know that you are more interested in learning than in the financial gain. I have a friend of mine. He writes to um, professors in Europe. He writes to them and tells them that he wants to collaborate with them on research for free. For him, it's the learning experience that counts. So if you reach out to someone like Bilal, for example, and he tells you, okay, he's working on one wind turbine design like that, you work with him, you learn from him. If he tells you, okay, I need to carry out this simulation, tell him to direct you to materials or resources that can help you learn simulation. Then, even if he is done with the project, repeat it, right? Do the same project again. Do the same project. Show Bilal. Let him guide you. You get, just just try and assist him on that project. That's just generally what I'm trying to say. When you've collaborated with people like this, with lecturers, students, or experienced engineers, you've collaborated with them and you've completed the project. You can add these projects to your portfolio, but you indicate that it was a collaborative effort with an experienced engineer, right? So this actually tells the recruiter or the selection panel that you are willing to learn and you are willing to collaborate. So another approach to take is to recreate published work. So there are a lot of research articles. If you go on Google Scholar now and you search for a topic, let's say simulation of a wind turbine, search something like that on Google Scholar, you'll see a lot of articles on that topic. Some people have written research papers on how to simulate a wind turbine. Some people have written research papers on how to manufacture a specific product, whether with 3D printing or with injection molding or with any other thing. So get those research papers, read them, and try to recreate what they've done. These papers, they usually have the entire process stated, right? So try to recreate what they've done. If the paper is hard for you to understand, send it to an AI model and have it simplify it for you, explain it for you like you are 10 years old, right? So try and recreate published work. When you've recreated a published work, you can have it on your portfolio. That's if you don't have any project at all. You can have it on your portfolio and indicate that this was a recreation of a published work. You add a link to the published work, right? So the idea here is not to try and you are an expert or anything. It's to try and show the recruiter or the selection panel that you are willing to work or you are willing to learn, right? So, and the next is a curiosity-driven approach. Investigate engineering questions methodically. So when I initially started learning to use ANSYS, I started trying to carry out simulations of theoretical concepts that I found in my fluid mechanics textbook. So back in 400 level, I read about this concept in fluid mechanics called drafting. And since I read about it, I was like, okay, when I start learning simulations with ANSYS Fluent, I'm going to try and investigate this. So that's what I did. In the process, it was a very hectic process. It took a lot of time and energy. I kept making a lot of mistakes, but at the end of the entire process, it improved my ability with ANSYS Fluent. And if I didn't have other projects that I had done, I would have included it in my portfolio. You can have something like that in your portfolio if you don't have any work experience yet. You can have something like that. In the what you say it was to investigate so and so phenomenon. Explain how you did it. Utilize ANSYS Fluent in using utilize so and so turbulence model. Then results. Just drag was reduced by so and so percent by the vehicle at the back and all that. So just try and investigate any phenomenon you may have heard of or any engineering concept that you've heard of, be it from your studies or from general interactions with people and social media, right? So work on things like this. They will not just improve your ability. They will also they will not just improve your ability. They will also give you something that you can use in your CV, in your portfolio, until you've gotten the opportunity to work on real industrial projects, right? And then try and solve real problems. Find practical problems and try and just develop a solution to it. I remember in the normally I dislike slicing onion, right? You know onion, and when you try to slice onion, yeah, it makes you cry. Like it irritates the eyes. So I really dislike slicing onion with knife. What did I do? I designed a dicer. Me and my friend, we designed a dicer, right? A manual dicer. It doesn't require using a knife, but at least it was better than using a knife. We designed the dicer. We produced the dicer with 3D printing, and we produced the blade by just welding and sheet metal work, right? We did those. That's not a project for any company. It's a project to solve a personal problem, right? Something like that. Now I can have it in my portfolio too. If I didn't have other projects to add, I can have it in my portfolio. So the idea is you just find problems that you have, real problems. It can be as something as simple as a cable holder for your phone or something. even that phone stand, if you can develop a better kind of phone stand, a smaller and more effective type, it's a problem you are solving for yourself. And when you design and you are able to 3D print it or produce it through any other means, it's something you can have in your portfolio. So this is for people who don't have a lot of work experience and as such don't have a lot of design engineering projects that you can have in your portfolio. You can use any of these strategies to get projects that you can have in your portfolio. And the added advantage is that this doing things like this will also help you get better at using other tools, whether it be simulation or in manufacturing. So yeah, that's pretty much it from my end. There is a It's the same structure, all the same. A what, a how, a result. Just try and tell a story with your project, right? And then for the awards and certifications, you can just add different awards, different competitions you've taken part in, and how uh, they've helped you grow as an engineer. Then the certifications can include certifications from courses that you've taken or cert- professional certification. So something like CSWA and CSWP, that's in Certified SolidWorks Associate, Certified SolidWorks Professional. These are professional certifications, right? These show that you are capable of using the software. But there are also learning certifications, like if you take MATLAB courses or ANSYS courses, the certificates show that okay, yes, you learned how to use the software, right? So any kind of certification that you take that you've utilized, if you have 50 billion SolidWorks certifications like Bilal. I know Bilal it has like 100 million right now. Because the last time I saw his post, he's already an expert like this. You have them in the certifications section of your portfolio. If you won some competitions, I know recently there was a SolidWorks at 30 competition, and they had a list of top 30 finalists, and the top 30 finalists were given a certificate. You can have that in the award section. If you have something like that, have it in your award section. So just do all these, and yeah, I said I'll also give you some additional resources. So a lot of what I've learned about developing portfolios and building my career as an engineer generally have come from two main YouTube channels. So you can check them out in your free time. The first is Engineering Gone Wild. So you can write it down. Engineering Gone Wild is a YouTube channel. It's mostly for mechanical engineers though, but also product engineers, product design engineers. So Engineering Gone Wild, you can check him out on YouTube. It's one of the most effective YouTube channels I've seen that gives a lot of tips on how to build your career as a design engineer. And then there is Tema Shaheen. Tema Shaheen, Tamer, then Shaheen, Shaheen. So Tema Shaheen and engineering, the whole template for the portfolio that I use, I got it from Tema Shaheen. So he's a very cool guy. He gives a lot of tips on building your career as a design engineer. He was an intern at Tesla at some point. So he gives a lot of useful tips. But Engineering Gone Wild is the best I've seen so far. So you can just check out these two YouTube channels, and hopefully we all achieve success in our efforts to build a good career in design engineering. So thank you very much. You can connect with me on LinkedIn, Emmanuel Ikegwonu. So I would really appreciate to meet with a lot of you, and hopefully we can build a lot together. So that's it from my end. Thank you very much. I think I'll be
Okay,
taking questions now.
okay. Thank you very much, Emmanuel. We really appreciate your session. I think there are a lot of questions even in the chat box while you were giving the
Okay, okay.
presentation.
Yeah,
Yeah.
yeah, I'm seeing some questions now. Okay. Wow, that's a lot of questions. Uh, Okay, what about GrabCAD GitHub versions for design engineers? Well, yeah, yeah. There is actually GrabCAD. Funny how I didn't even remember that. There's GrabCAD. Yeah, GrabCAD is a good place to also attach your 3D models. It's a good area. Just I don't think it has as much PR that GitHub has for programmers. But I think GrabCard works. GrabCard works. But at the same time, if you know a friend who's a programmer that can build something better, something something closer to GitHub for design engineers, I can pitch it to him. That's a good startup idea. You come and give me my share though. Give me my 10% for giving you the idea. But uh, is there any free voucher for CSWP on this session? I don't think so. I think that's a question for Bilal to answer. So,
I've
do you
answered that.
think, okay, do you think showing failures or iterations strengthens a portfolio? How should it be framed professionally? Well, I feel if you don't have a lot of projects, right? A, if you are still a beginner, if you're still a beginner, you don't have design engineering projects, I think it's good if you show some failures, right? Or show iterations. So if there is, let's say you worked on only one or two projects, for example, you can expand on those one or two projects in multiple pages, right? Showing how you tried this, you failed, you tried again, you failed, you tried again, and then you got this. That would be advisable. But if you have a lot of, you've done up to like five different projects, then I don't think it's necessary. Just put the five projects in the same structure that I explained: what, how, results, right? So if you have a lot of projects, this might not be necessary. But if you are still a beginner, this yeah, I think this is advisable. This is good. But how can everything fit on a page? Does it not make it look bulky? Okay, okay, yeah, there are different approaches you can take to this, right? So I didn't show you the entire stuff. So there are different approaches you can take to this. For example, see this now. I put two projects on a page, right? The what, the how, the results, they are all here, but both of them are on the page. These are the less significant projects that I have done. So I just put them towards the end. So these are two projects, they are on the page. You can do that, absolutely. But in a case where someone like me now, I'm looking to specialize in the energy sector. So I need to give a lot of technical details on the stuff that I did, right? See this one too. The what, the how, the result. That's an entire project. And in this case, to the what, the how, the result. You see, there are two projects on one page. You can summarize it. You can make it as summarized as possible, right? But it's just that in my case, for these, the projects that I consider the most complex that I've done, I have to put a lot of details. So you can decide to use an entire page for one project. You can use 2 pages for one project. In this case, I used 2 pages for one project. The what and the how were in one page, and the results were in another page. Right? I used 2 pages. It's all up to you. If you feel like giving more enough detail on the project. For someone like me, if I want to apply for an energy role, I'm not going to put 10 projects on my portfolio. No, I'm going to put 3 or 5, right? I'm going to put just 3 to 5 of the highest projects that I've done. So that's why putting in more details, I felt the need to have a lot of details like this. But if you want to upload up to like 10 of your projects or more, then you can simply go with this. You can go with this strategy. Sorry. You can go with this strategy, right? Have your entire project, have 2 projects per page. You can go with this approach. It's just all up to you and what you feel the recruiter is looking for. Like me, in the programs that I am applying for, the value detail, right? The value detail. So that's why I put a lot of detail. So it's just up to you. You do your research on what you're applying for, whether it's a scholarship or whether it's a job application. Do your research on what they require and tailor your CV based on what is required, right? So if from your research you understand that these people love detail, try and put more detail on your portfolio. But if you research and you see that they don't really value detail, like they just they just want to get a glimpse of what you've done, then you can absolutely structure it like this: 2 projects per page. I think that's how Tema did his own too, right? Two structures, 2 projects per page. So that's for that question. Yeah, this is Yvonne. Yvonne, did I answer your question? Okay, I don't know if. Sorry, I didn't get you.
No, no, you did. You did. Thanks.
All right, all right, all right. That's good. Um, David, David Omolewa, did I answer your question? If you are still confused, you can tell me. Oh, like I'm not. I'm okay with you not answering at this point. So I just want to confirm that you answered what I said. You understood what I said.
Yeah, understood.
All right. So can we get a link to the slides? Okay. Bilal, I don't know. Can I send it? I think I can slides to the group chat. I want to believe everyone here is on the Lagos SOLIDWORKS Users Group chat. So I think I will send the slides to the group chat. Is it possible to
Yes,
add
yes,
video?
fine.
Okay. Is it possible to add video or animations of project workings and mechanisms? Well, you on Canva, because this was done with Canva. On Canva, you cannot add videos, but you can add a link to a video. I have something like that on my project. So on my portfolio, sorry. I have, yeah, there's a section of my portfolio called creative works, right? So I, I added my YouTube channel. Like I said, this is a master portfolio. It's not like when I'm applying for certain programs, I'm going to include this. It's just specific programs that care about your creative contributions that I'm going to include stuff like this. But you can see from this section, I put a link to the YouTube video, right? So on Canva, you can actually attach a link. So if this appears as a PDF, when you click here, it's going to take you to the YouTube channel and to the specific videos. So if you have a video that you want the recruiter or the panel to access, you can simply add it as a link. But I don't think you can put a video in Canva. It might be possible, but I've never tried that. So, but what I know you can do is you can attach a link to whatever video. So you just have the video on your Google Drive and then attach a link to that video in the Google Drive so that when they click on it, they can access it. But I would recommend try and express your work or your projects in pictures pictures first before thinking about video, because these are recruiters. They might be looking at thousands or hundreds of applicants, right? They might not have the chance to go and be watching videos. So ensure that at least your images tell the story, right? Because how these things usually work is they might see, okay, we have 1,000 applicants. They will just rush through your portfolio. If they like what they see, you might qualify to like the top 100 applicants. Then in among those top 100 applicants, that's when they'll start looking at details. That's when they'll settle down to start reading the details and to start clicking links to videos. So just try and ensure that the pictures, the what, the how, the result can tell the story of the project you are trying to communicate first, right? Ensure that that one is done, is settled before thinking of okay attaching links to videos, because that initial criteria is what's going to get you above the thousands of applicants into the like finalists, right? So that's it for David. Uh, how do starters or early careers navigate this position? I think I already answered that with the slide, right? So if you don't have any design engineering projects, there are a lot of things you can do. Work on personal projects or collaborate. Reach out to find people on LinkedIn. The beautiful thing about LinkedIn is when you start posting stuff related to design engineering, it will start showing you more and more posts from other design engineers. It will start oppressing you with with the projects that other design engineers are doing. So when that operation starts, connect with these design engineers and ask them for opportunities to collaborate. Reach out to your lecturers, your mechanical design lecturers, your thermodynamics, fluid dynamics lecturers, and tell them you want to work on them. You want to work with them on certain projects, right? Tell them you want to collaborate, you want to assist them. Reach out to experienced engineers, and then after working on this project, you put them on your portfolio. But in putting them on your portfolio, indicate that this was a collaboration with a more experienced individual, right? So indicate it won't harm your portfolio. It won't harm as far as you're applying for an entry level, it won't harm it at all. So then try and recreate published works, find research articles. I think I will even show you this one live. So let's say yeah, you want to go into energy, energy systems, right? So simulation of a wind turbine. Just go on Google Scholar, type a project. You'll see a lot of articles on them, right? See offshore wind turbine load simulation, modeling and see this one, modeling and simulation of a wind turbine generator system. You will find a lot of projects. Try access these projects. Just go to this PDF section. This one is not working. Well, click on this link here, download the PDF, and read through the article. Read through the article, understand how they did this, and recreate it, right? I don't know why these links are not working, but hopefully you already get point. Just go on Google Scholar. This is Google Scholar. See it here. Type a project. If there is anything you are interested in, it doesn't have to be a wind turbine. It can be anything else. It can be, let's say, manufacturing a uh, a let's say vehicle tire. I don't know. I'm just thinking of things from my head. You will see a lot of projects. Okay, this one is life cycle assessment, assessment of radar tire manufacturing processes, performance analysis of tire manufacturing system. So you will find a lot of projects on these topics, right? Download these articles, read through them. Some of the articles may be difficult for you to understand. That's okay. Paste them on cloud or ChatGPT and have it break it down for you, right? Then recreate these projects, recreate them, and when you've recreated them and your results align with the results in the article, then you can have it on your portfolio and indicate in the portfolio that this was recreated from so and so article published in so and so journal, and attach a link. You get. In some cases, when you try to recreate a published work, your results might not be exactly the same as the results they got. Let's say in the article they reduced consumption by 21%. In your own, you reduce consumption by 22.05%. Indicate it in the portfolio. Say there was a so and so percentage difference from my results and their results. But generally, this difference already matters since it's not significant. You get. Recreate the published work and you can have it in your portfolio. Try and solve, curiosity driven, try and solve your own, try and investigate engineering phenomena, engineering principles, right? Try and investigate them. Do just, if you've observed anything from your coursework, try and recreate it. Like I remember one other time I watched a YouTube video where they said, in the YouTube video they said that Tesla, Tesla, at some point they were considering removing the side mirror of their cars because they said it will help reduce aerodynamic drag and help increase energy efficiency. That's what he said. So I actually investigated that stuff. I got two vehicle models, one with side view mirrors and one without. I ran a simulation on both and compared the drag coefficient of both. If I didn't have other projects that I had worked on, I would have had these projects in my portfolio. So just investigate engineering concepts that you've heard of, whether in the classroom or on social media or from your friend. It can be a claim that your friend made. Your friend said, this this car is faster than that car. Get a model on GrabCAD of these two cars and run a simulation on them. You can have things like this. That's if you've not worked on any project before. And then try and solve real problems. I talked about the problem I solved with a dicer, right? So that's for this question. Sometimes we don't have prior knowledge or experience in that field or have related projects. So just let's say I'm sorry I'm taking time to answer this. But let's say all your projects are related in the energy sector and you don't have any project in the automobile sector. These strategies also apply. In this case, Do we find people who are in the automobile sector and collaborate with them, or find research articles in the automobile sector and recreate them, right? This strategy is also apply. So that's for David. Now, can you recommend tools for dynamic portfolio and transfer to self-hosted websites rather than saving PDF apart from those popular websites you listed? I can't really say I understand this question, but tools for creating a portfolio, there's Canva, there's PowerPoint. Okay, by dynamic portfolio, I think you mean portfolios that are not static. Maybe something that if you make a change today, anybody accessing it will see that change. Mm, this is why we need a site like GitHub, like this. Like we need a website like GitHub. But I don't really know. But I can do some research on that. That's for David. I can do some research on that and get back to you. But for now, I don't
Sorry,
really.
let me come in there.
Okay.
Most company would not, I think, accept links as a this thing. Their training is majorly on phishing, or how they call that thing. So you cannot just send a company a link and expect that they will actually open the link, because they are trained to actually not click on links, because you don't know what is behind the link. You get?
Oh,
So I will not suggest that but you can host it on your website, yes, for personal, maybe sharing with friends and all, but to company, uh, it should not, it's not a good practice.
okay. Okay.
Sorry,
Well,
the reason why I asked that question is, let's say I'm also like someone that is also applying to jobs and all those things. So I'll say like for most of the jobs I've been applying for, you see, especially there, once they ask for your CV, cover letter, they don't necessarily put space for uploading PDF document. Sometimes they just put it there,
okay. Okay.
link
Yeah,
to
I covered that. I
portfolio and
covered
all
that.
those things. So
Yeah, I
most time I
covered
don't
that
have
in
any
the
portfolio, so that's why I leave it blank.
yeah, I covered that in the during the presentation. In cases, in situations like that, they will ask for CV, right? Now, in your CV, you can have a section titled project, and then write uh, and then put a link to a Google Drive in that section, right? Put a link. Or you can have a section just called portfolio self. Put a link to a Google Drive. Then upload that your portfolio PDF in that Google Drive. I've done it multiple times, right? Upload the PDF in a Google Drive and provide a link in a portfolio section in your CV. That way, when you submit the CV, when they read through your CV, if they are interested, they click on that link in the portfolio section and then they can access your portfolio. You get?
Yeah.
Okay. So, mm, Abdullah, I have done quite some projects on design and manufacturing. Creating a portfolio was all I needed. Thanks. Oh, that's good to hear. You see, I haven't really done much on manufacturing, but I have a bit of idea on additive manufacturing, 3D printing. So, uh, I just included those there, though I'm not looking to specialize in that area, but I just included them. So there are a few things that I would let me just quickly show you one particular section. Okay, yeah. So this is one project I did for a company. So when you are doing things like this, in the how section, sorry, in the how section, yeah, it will be good for you if you explain. Like I said, how is about methodology that you took, right? Methodology and the processes that were taken to uh, undergo that project. So in that section, try and include utilizing design for manufacturing principles. In this case, design for additive manufacturing, that's DFAM. So just try and give little details like this because I've seen that in a lot of design engineering roles that involve manufacturing, they want to be sure that you understand that not every design can be translated into manufacturing. That you understand the principles behind turning a design into manufacturing, especially subtractive and formative manufacturing, like injection molding, laser cutting, and all that. So try and indicate those principles try and indicate that you utilize those principles in the entire process, right? So, but overall, I'm glad I was able to help you with that issue. Okay, David provided a link. Let's see. So what's the question? Sorry. David, what's this link about? Okay, what's your critique on this style of portfolio someone sent to me? Okay, critique. Technical design. Okay, okay. Okay, this is nice. This is nice. But then my critique would be, it's not really telling a story, right? So all I'm seeing here are images. I don't know what these are. I know this is a steering wheel, but then it's a steering wheel. Then what, right? I don't have any idea what this is. Yeah, it's a structural analysis. Is it? This is probably a cantilever beam, or it's not even a cantilever because it's looking like it's fixed at both ends. But like there is no detail here. It's just an image with contours, right? This is just an exploded view. These are just images. They are not telling any story. They are just there, right? They are just pictures. So there's no story here being told. So I'm not really convinced. For all I care, this may not be your project, right? This could just have been something you screenshotted from YouTube or you took from a grab card, right? There's no story. There's no story being told here. And then these write-ups, these are probably things that could have been in the CV, or if they are associated with these images, I cannot connect them. I cannot make the connection, right? So that's why when you are doing a portfolio, you should try and first of all structure it properly. Ensure that what you are writing is next to the image that you are attaching, right? In this case now, you said you perform mechanical design calculations, including shafts, gears, couplings, and levers. There are no quantifiable metrics here. Perform mechanical design calculations. What problem were you trying to solve? What were the results? What did you increase? What did you reduce? What did you observe? Conducted FEA analysis for structural verification and performance validation. Okay, what kind of FEA did you conduct? Is it a static structural analysis? Is it a transient analysis? Is it a thermal analysis? Is it structural optimization, topology optimization? What did you do? Optimize material selection and design parameters for cost reduction. What tools did you use for this? Is it ANSYS Granter, ANSYS Mechanical? Like there are a lot of, it's leaving a lot of questions, right? It's leaving a lot of questions. It's not really telling the story. It just feels like name dropping. I'm sorry. It just feels like you are listing stuff, right? So there is no connection, there are no quantifiable metrics, and there is no story being told, right? So that's why I feel don't separate write-ups from images. Put them, whatever you are writing, attach an image that describes what you are writing. Like this. You don't see me writing what, how, results in one section and then putting the images in another section, right? So at least in the what, when they read it, they understand, okay, this was the goal. In the how, when they read it, they say, okay, uh, top and bottom casings were split into two each to fit on the print bed. And they see the image, they see, okay, the top and the bottom casing, they were actually split and they are on the print bed. Then in the results, they, like you see, the descriptions are next to the images. So that way it's difficult to get lost. You can actually make connections. Same here, develop this dynamic simulation model in MATLAB and Simulink. This is the simulation model. They are seeing it as they are reading it. About 87% dedicated to electrical heating. They are seeing the 87.38% energy consumed by heating. So it's easy to make connections, right? After describing integrated a 2 meter square evacuated tube solar collector, they can see the evacuated tube solar collector. So they are not isolated. The descriptions are not separate from the images. You have to put them in the same area so that as they read, they can get a visual idea of what you are trying to say, right? And what else? So yeah, that's pretty much it. So my recommendation would be to, even if you are trying to do it, take it as a website, the experience is good. The experience are they're actually very, very impressive, very, very impressive. Honestly, very impressive. It just needs better communication because the truth is, majority of people who are going to be applying for the same jobs as you, they will probably have something like this, right? So you need to be different in the sense that you are your approach, your projects are telling a story. There is a what that explains what you are trying to do. There is a how that explains how you went about it, and there is a result that explains the outcome. It's quantifiable that explains the outcome with quantifiable metrics, right? Quantifiable metrics. So don't just say you perform mechanical design calculations, including shafts and gears and couplings. No, say yes, this is like a how, right? This is like a how, but you have to explain what these calculations were done for, like what specific projects were being used for, and what were the outcomes. Did your calculations align with experimental results or with simulation results, or did you use calculations to verify and validate your results? Right? These are, it just has to tell a story. That's just what I'm saying. But overall, the projects are really impressive. They're very, very nice. They're very, very, very nice. All I'm saying is it just needs better structure, as I've been mentioning, to try and tell a story this with these projects, right? Yeah. As a design engineer, do you recommend we go into specific field or we should be broad? Okay, yeah, this is a question that I've actually battled with a lot, right? So I've thought about this several times. Like it has really baffled me because I'm a big fan of generalizing, right? Of spreading my tentacles in different areas. But I feel as a design engineer, you are not exactly limited to a specific field. I feel the moment you decide to the moment you decide to specialize, then you are more of an engineer in that area that you are specializing than a design engineer. I don't know if you get, like someone like me, uh I don't refer to myself as a design engineer most times. Most times I like to refer to myself as an energy systems engineer because that's where I want to specialize in. But for the product design engineers, for those who are not for those who are not specializing, I feel like they are more qualified to be called that name, design engineer. But I don't recommend anything. I feel it's up to you. It's generally up to you. For someone like me, I've always wanted to go into energy, right? So design was like a means to get into that sector. But it's all up to you. If you want to be the type that can work across different companies, right? Though that's not limited to a specific sector. You can go ahead and be a design engineer. As a design engineer, you can work in product, you can work in health, you can work in energy, you can work anywhere. You can go ahead and do that. But then there are certain people like me who who want to specialize in an area, right? So that it's what I'm just trying to say is it's all just based on your decision. It's up to you. But if I were to recommend, it won't be that simple. It's going to be actually be based on your interest. I would recommend specializing first and then generalizing later. There is this thing called the hourglass approach. You know, an hourglass now is wide at the ends, but it's narrow at the middle. So the whole idea behind the hourglass approach is you start out broad, then you start to specialize. Then you get to a point where you specialize and then you expand again, you generalize again. So I don't know. You can take that approach. Specialize, find a field that you are interested in and specialize initially. Then when you've gotten enough experience and enough capital, money, you can then decide to branch out to other areas. But overall, I just feel it's up to you. Secondly, how much experience does one need to be job ready as a design engineer? And is it possible to learn on the job? It's very possible to learn on. That's pretty much the essence. That's the most important factor I consider in working a job is the learning experience, right? Not even necessarily the salary, the learning experience and the connections. Those are what I feel are the most important factors in working any job. That's why I often tell some of my friends that if you are not really learning where you are working, then ensure that at least you are earning. But if you are not learning and you are not earning, then you need to leave that job. That's it. But how much experience does one need to be job ready? Okay, let me give a small confession, right? So I got my first product design job when I was in 400 level. It was at a company called Terra Industries, right? So the job entailed designing drone parts, right? UAV parts. And when I got that job, I was working with SolidWorks for only about 2 months when I got that job. Just 2 months. Right. So I was not an expert. I was still like a beginner. But what I usually did was that when I learn a design on YouTube, I post it on my status. Right. So a friend of mine saw some of these posts and then he recommended me for job. So I was still like a beginner when I got my first product design job. And we were about 4 to 6 design engineers in that job. And every other designer that I saw there, every other design engineer that I saw there was operating at a much higher level than me. They were operating, they were operating at a much higher level than me. So that in a way forced me to improve, right? Let me try and give an informal example here. You guys all know Ben 10, the guy with a wristwatch that can turn him into any alien. In that same Ben 10, there is Ben 10 Ultimate Alien, where the whole idea was this is aliens. They simulated an environment, the worst possible environment for these aliens to be in, and the aliens had to evolve. So the aliens became ultimate, like there was an ultimate humongous or ultimate echo. Like they were born from a stressful environment, a highly pressured environment. So what I learned from that is that most times growth comes from pressure, right? When you are doing a project, if you're a beginner and you enter a sort of design project, by the time you come out of that project, you are much better than you were before. That's what I experienced at Terra Industries. So I saw the other design engineers, they were producing wonderful designs. I was like, can I actually recreate this? This design is so insane. So in a way, it forced me to level up. After I saw some of the designs that they did, I spent up to 16 hours a day practicing design, right? So I entered with very little experience based on a referral. But because of the level at which the other engineers were operating in, I was forced to level up. So that we can classify that as learning on the job now. Definitely we can. So to get to get a job as an inexperienced engineer, you don't need that much experience to get a job. That's one thing I can say because I'm an evidence of that, right? But the thing is, most times when you are getting into a job without much experience, it's most likely going to be at a startup because I don't high large companies will hardly hire you without experience. So the best kind of experience you can get if you are just starting out is going to be from a startup, right? Terra Industries was a startup. My first three, the first three product design roles, both full time and contract that I got, they were from startups. So those are the best areas where you can get experience. And then I would also advise, I know this is going to be a difficult advice, but if you are just starting out, you don't have experience, then learning should be your priority, not salary. Right? Don't pressure the company with salary or payment. Just get focused on learning and building your experience. That's the advice I will give. So just to summarize what Isaac Egu has asked, do you recommend going into a specific field or should it be broad? I believe it all depends on you. It all depends on you what you are interested in. If you are more attracted to a specific field, specialize in that field. If you want to keep your options broad, then just be broad, right? Uh, but a good recommendation. Don't I'm not setting it in stone, but I think it would be nice to specialize in an area initially and then diversify from there. Then secondly, how much experience does one need to be job ready? I don't feel you need so much experience as far as there are startups that you can work or learn from. You can apply for internship roles. You can start as an intern, right? In companies or startups, right? And as a design engineer, is it possible to learn on the job? It's very, very possible. In fact, that's pretty much what you do as a design engineer. Because when you enter a job, you will always see someone who is better than you, and his performance will inspire you to grow, to improve, right? So I hope that answers it for you, Isaac. Isaac here. Okay. So Hi, Emmanuel. Okay, okay. Thanks. I work R&D product development. Where the how, where the how part is mostly confidential. How can we balance the portfolio then? Yeah, this is a very good question. This is a very good question. Okay, I definitely relate to this because one of my projects actually has an NDA, a non-disclosure agreement attached to it. So we couldn't really post specific details like dimensions and all that. We could have the pictures. We could have the pictures because it's already commercial. Like the product has entered the market, so we could have pictures of it, but we were limited in what we could show. So in that case, you basically you. I think I'll need to get more detail on what that project, on what that product is. That's one thing. I'll need to get more details on what the project is all about to be able to give a balanced uh, recommendation. But in my own case, I feel if you state that you are doing product development and you utilized design for manufacturing principles, you utilize SolidWorks for specific design. I think that's you will not be breaking any confidentiality agreement by doing those. I guess what I'm trying to say is you can be broad in your description, right? You don't have to give specific descriptions, right? Like, let me think of an example. Uh, uh, I need to think of I need some time to think of an example for that. But what I'm just trying to say is you can be broad in your description. You don't have to explicitly state that this is exactly what we did. You can just simply say um, we used computer-aided design tools to work on this. I don't know if you get. Sanjay, would it be possible for you to give me more detail on this particular question? Is Sanjay here? Okay, you know what? I'll take note of this question and maybe in the group chat we can address this better. We can address this better.
Okay,
Okay, it's around. Okay.
okay. So I mean, I kind of work with R&D product development for IIT.
Okay.
So it gets to share in the how part of it. That is the simulations or the statistics or how we approached the problem. I can give an overview, but I really can't
Okay.
go into the specifics like you said.
You can't
So
go in depth.
I mean, yeah, I mean sometimes like it will be in the stage of patenting and stuff like that. When it is
Oh,
in that stage, it becomes patenting is an elaborate process, a
yeah.
year. So you have to wait for it, and it becomes pretty hectic when you are working with portfolio development. So I thought, okay, how can we counter that?
Okay. Okay. Like I said, in situations like this, you just you just stay broad, right? Like you said, you just give an overview, and then you indicate that more details cannot be presented due to the confidentiality agreement involved. You understand? You can just give a broad description of what it is. So uh, let me use this as an example. So let's say, for example, I'm not allowed to share any of this. I'm not allowed to share any of this project that I did with the research center. Let's say I'm not allowed to share any of it. Then this aspect, energy demand, was found to be so and so per batch dedicated to electrical heating. I would not include it in the portfolio. I would just keep it at developed a dynamic simulation model in MATLAB and Simulink to quantify the energy demand of the entire system and its individual subsystems. Full stop. I will not give any specific value or any quantifiable metric. I won't add that, right? I'll just give a broad overview. I would not even add the optimization strategy since we are not allowed to talk about all that. Just give a broad description. No need to go in depth, right? So you can just keep things summarized. And in the results, you can just say achieved reduction in grid energy consumption. You don't have to put the specific value. You can just say achieved, you can just keep it broad, like, right? So achieve the reduction in grid energy consumption. Then you add a section that says due to the confidentiality or the confidential nature of the work at IIT, we cannot give specific details of the results. You can just include something like that, right? But then if you have projects like that, then you would have to make up for them with this strategy. You have to work on your own personal projects because if your portfolio consists of solely uh, uh, projects with non-disclosure or confidentiality agreements involved, then it might really put you at a disadvantage. It can really put you at a disadvantage. So what you should do in cases like that is work on your own personal projects or collaborate with others on specific projects so you can add them to your CV. That way you can add them to your portfolio. That way, your portfolio now comprises of not just confidential projects, but then a mixture of confidential and personal or collaborative projects. You understand? So that's what I think you should do in situations like this. Did that answer your
Mhm.
question?
Yeah, yeah, Emmanuel. I think now it's
O-
basically a good, way to go ahead. I think. Yeah, thanks for that. Very helpful and great session, by the way. Thank you.
All right. Thank you very much. Thank you very much. Okay. So, do we have actual manufacturers in Nigeria like PCB, Way, and others? Well, we do in Nigeria, but sadly we are limited compared to other developed countries. I know definitely the Terra industry is manufacturing drones in Abuja. There is Tranos in Lagos. Uh, there is Vigas in Benin. We have a few of them, but they are not that much. There is this company, Nigerian Foundries. So we have a few of them. They are not much, but we have a few. So in cases like ours, since we don't have a lot of actual established manufacturers in Nigeria, you have to keep an eye out for the startups. Okay, so you can use the startups as a foundation to build up your experience, and then see if you can get international design roles. Don't also limit your options to companies. You can do a lot of contract work, right? So especially in universities, there are a lot of lecturers or professors trying to execute one or two projects. You can work with them, they give you a contract, you do the work for them, and they pay you, right? There is that. Or you can set up your own manufacturing company. That's also an option. You can set up yours too. Like the dice that my friend and I designed, we were actually partnering with a professor to like set up a factory to start manufacturing them. So things have been slow right now, but it's still a plan in the works. So yeah, we may not have a lot of manufacturers in Nigeria, but there are a few you can work with. Then you don't have to keep your options limited to manufacturers. Also look outside the country, look at universities, and look at contracts. So there's that. Mm, to answer that, your portfolio consists mainly of personal projects, not company projects. Wait, are you trying to answer Sanjay's question?
Yes, yes, I think so.
Okay, okay. Yeah, that's actually quite true. Yeah, portfolio is to show your skill, not your industrial experience. Yes, this is actually very true. This is why I emphasize on showing technical rigor. One of the rules for creating a good portfolio is show technical skills, right? Hard technical skills. So it's not enough to just say uh, we did this in the company. You have to explain what exactly it is you did and it should be a technical skill, whether it's manufacturing or simulation or analysis, right? So when you understand that having hard technical skills is a core part of building a strong portfolio, then it doesn't become entirely compulsory that all your projects have to be done with a company. Don't get me wrong, the projects done in a company might be valued higher than your own personal project by some recruiters. Yes, they might value projects done in a company higher than yours, because in your own case it's easy to fix certain things now. It's not like they are going to be looking at the entire detail in the project. You can easily, in their based in their own opinion, in their mindset, you can easily fix certain things with your own project. But if it is a company, it's like there is an external validation of that project. You get, with a company, it's like there, you were under the supervision of a higher entity, so they might value it higher than yours, than just personal project. But then it's just good to have a mix of both. It's good to have a mix of both. But in situations where you are applying for entry level roles and you don't really have the experience, then personal projects actually work. So what Samuel said is true. Portfolio is to show your skill, not necessarily industrial experience. Right? How do we actually find these startups? LinkedIn. LinkedIn, there are different sources. Just mostly LinkedIn though. LinkedIn, and one thing about LinkedIn, as I said before, is the more the more active you are, the more uh, the more posts tailored to you you will get. Like I said, when I started posting on LinkedIn, that's when I started getting posts from other individuals and other companies, right? So when you start posting a lot, let's say you want to specialize in automobile industry, and you start posting more and more on things related to the automobile industry, before you know it, you start seeing posts from others who are in the automobile industry, right? So you might then see a post from a certain guy who is a senior engineer at a certain startup. Like I remember when I started doing simulations, computational fluid dynamics simulations on vehicles. That's when I saw a post from a guy in one electric vehicle company in Lagos, an electric vehicle startup in Lagos. I can't remember the name now. I think it's EN1 Technologies. EN1 Technologies. So just about 2 days after I made a post as to how side view mirrors can increase aerodynamic drag of a vehicle, about 2 days later, I saw a post from a senior engineer at EN1 Technologies, a startup in Lagos, building electric vehicles. So the good way to get access to a lot of these companies, just be active on professional networking sites like LinkedIn, right? So the more active you are, the more the LinkedIn algorithm throws individuals that are related to you in terms of interest or job prospects. Start showing those individuals at you. You start seeing more of their posts, and then you can reach out to them via LinkedIn, right? And then there's also the fact that the more you if you are the type that builds in public, let's say you document what you are learning, both for your close friends on WhatsApp or for the general audience on LinkedIn, you start getting more referrals. I told you before that my first product design role came because someone saw what I posted on my status, the design that I posted on WhatsApp, right? So generally, the advice I give to finding more of these startups is increase your activity on professional sites like LinkedIn. And then there is also the Google and AI option. Just go on ChatGPT, all right, or cloud, and type search through the internet thoroughly and give me a list of most the 10 the 10 most valuable startups in hardware in Nigeria, or the 10 most valuable hardware startups in Nigeria. Try something like that on LinkedIn. Then all the options that it brings up, you check through each of them one after the other. Check through their websites and search them on LinkedIn. Right. So be more active on social media and then do some research. That's why AI is actually very nice, because if you were to go through the normal Google route, you have to do a lot of digging. But with AI, you can just type it and it will give you a list of options, right? So that's one way. Those are a few ways, right? Uh, I joined late, so I don't know if you mentioned. No, I didn't actually mention it. I didn't mention it. I didn't mention it. So I guess that should be it. I hope everyone is satisfied with the answers. Please, if you are not satisfied with the answer, feel free to speak up, right?
Oh,
Please.
I do not think we have that much time again.
Oh, wow! I even lost track of
Yes,
the time. It's 11:53.
yes, yeah.
Okay. Okay.
So thank you very much for the great session. I think even everyone here can attest to the fact that no, the session was enlightening, and then it will even boost everyone drive. I think everyone would be willing and then able to create their own portfolio with everything that I have explained. The link, the link, and then the presentation slides will be shared to everyone on the group so we can have access to the session and everyone will be able to learn more and watch it again in case there are some things he said that maybe we didn't get or something. So thank you very much, Engineer Emmanuel,
Yeah, you're
for
welcome.
this great session. And I don't have 50 billion certificate. Oh. so so yeah, thank you very much, everyone that stayed with us from the beginning to the end, and everyone that joined us maybe in between. So we really appreciate you taking part of your time to be with us here. Yes, and then we'll be sharing the YouTube link on the group chat. That's for the recording, so everyone can go back to it and maybe see one or two things that you didn't get before. Uh, okay, so yeah, everyone is just thanking you on the group chat, so you can check that out. Uh, with that, we'll call it an end to this great session. So thank you very much again to everyone, both our engineer and then everyone that are in participants. Thank you.
All right, guys. Thanks for having me.